Yeah, thank you very much. No, I love this kind of stuff. I tell people when I'm not up on stage that really the only reason I give talks on stage is that it makes it easier to have conversations afterwards.
Yeah, we're shortcutting. We're
Yeah,
jumping
that
right into the doing this together.
yeah, and this is the 21st century, and so when you can find people, such as yourself, who's able to make these introductions and just makes that starting the conversation that much easier. Uh, that is exactly what I love, and I hope as we move into the future, we can have more of these. Thinking about slightly into the future, people sometimes, when I talk about the future of education, and they say, are there going to be very large groups teaching? I'm saying no. In the future, I think there will be connections of people and artificial intelligence and other tools, which will connect one person with the 10 people that they should be teaching, and connect one person with the 3 people who can teach them. And so it could be billions of people in small groups, not one person talking to a billion people.
Yes. Kathryn, again, thank you so much for being here for sharing. I think we've met for the first time at the Singularity Summit in Berlin, and
I
we
think you're
share,
right.
share love and spirit for what Singularity University stands for, and bringing it out to the world that there's something happening, and we have a lot of good things, but we don't have so much time. So hopefully a lot of people soon understand how they can contribute and shape the future we're steering towards. And for me, you're a big shaper and inspiration. I love our connection on social, which is the bridge that we have between the two continents for now. And I'm really thankful that you're, as I said, that you're here with us here today. I'm kind of segueing over to you. I want to pass this virtual stage over to you.
All right, yes. What I'm going to do is I'm going to give a presentation with some background ideas, which I found useful to share, and that having them then moves right into a conversation. Uh, Part of what I've been doing, as he mentioned, that we met through the Singularity University Summit, and the Singularity University is an organization which I had the great honor to be able to help get going. I was on the team of people where when Ray Kurzweil and Peter Diamandis had an idea, we should build this place. Well, when somebody has an idea to build, what do you need to do? You need to have a blueprint, and then you need to build it. And so I was on the team of people. We put together that blueprint and started it. And that was back in 2007, right? It was 13 years ago. That's like a million years in normal time, it feels. And there's a lot of lessons that I gained working with all of the attendees, people such as yourself, people who want to come together and learn from a diverse group of others about how to just not just how to use technologies, but how to work with other people who are using technologies. And so uh, the the core ideas that I'd like to bring forth. And a lot of these, it is about technologies and it is about the people who know how to use them, but it's really about how technologies and experts and all of the rest of us are able to work together. All right, all right, just a moment. Let me get going. So when we're talking about just moving forward, of course, this is what I was thinking was going to be happening. Life is an exploration, and we don't know what's around the corner, but we have some expectations of what it could be like. And of course, now 2020 has changed into something entirely different and beyond our expectations. And so these tools that I've worked with, these conversations that I've had, they've become more important than ever. So I'm going to talk about exponentials and exponential technology. I know you've been hearing about them, so I'm going to be reminding you about what you know, not necessarily going over things from scratch. And then I want to talk about experts, or instead of experts, you could call them smart people, which are, whichever one you want to think about. So exponentials, yeah. When we hear about exponentials, people use it to mean just things that change really rapidly. And they do change rapidly, but on other cases, you can have an exponential, like the growth of an economy is exponential, but it's a very slow exponential. An economy might double every 20 years or 100 years. Or your bank account, if you have an interest rate, it could be exponential. But again, if you know where to get a 10% interest, let me know. But a lot of times now it's 1% interest. So again, it's doubling at a very slow scale. But with technologies, it changes a little bit faster. So, again, our intuition about exponentials, you have to spend time walking through them, right? Because, you think about just the act of doublings, right? You start with a baby and you double the baby's speed. It's a little faster, it's a little bit faster, and now you're walking, and 5 doublings from a baby gets you to runners. And all right, that makes sense. That's within our experience. But now let's double that again. You have a fast runner, you double that speed, you're into car range, you double that, and 5 doublings from a runner gets you into, again, the speed that we might have forgotten now, but we're hopefully getting back to this at some point, perhaps. The speed of an airplane. Now, this though is where it starts getting, how do you think through this, right? You double the speed of an airplane, well, now you have a very fast airplane. You could have a Concorde, and a couple more doublings than that, then you're starting to go into rocket territory. Well, if you go from an airplane and you double that 10 times, well, now you're talking about something faster than any human has ever dealt with, unless you're a physicist. And 10 more doublings after that, you're talking about the speed of light. So 30 doublings gets you from the speed of a baby crawling to the speed of light. And this is, sort of, all right, this is mathematical, you could say, but how does this apply to our lives? Well, it applies to our lives because exponential technologies share this very quality. I have been working, with exponential technologies for longer than this, but 15 years ago, I had the opportunity to work with Ray Kurzweil to be a research analyst for his book, The Singularity is Near. And there he was making points about how these exponential technologies, they have been around with us longer than we think, and they have patterns which are stronger than we think. And so, for example, if you look at what we were dealing with 120 years ago, well, we were dealing with calculating machines, and we were able to move at a relatively, a human pace. And then as the years go by, these technologies, what's available to us, and not just what's available to us, but what we can do with it and how many people have access to it, has slowly but steadily, but it's not slow, changing such that now you have people who are able to do more in a second than all of humanity could do 120 years ago. And even though it looks slow and steady, there are points where things change immensely, right? If you think about the 1940s and who a computer was, right? Here's 4 computers in the picture, right? Because computing used to be what humans did. And then slowly, but not slowly, computing was turned into digital computing, and the amount of work that one person could do in a day, a computer could do in an hour, a computer could do in a minute, it could do in a second. And these sorts of changes, we talk about it as being sort of a 20th century change, but it isn't. It goes back even further than that. But when you look at the changes, between 1850 and sort of for 100 years, these tools available to us were, they kept on getting a little bit better, but then you get these inflection points where you have a change, where you have digitization, and the amount of computing just starts to go up like a rocket. Or think about what we dream and what we imagine, right? Now it's over 100 years ago that we first saw the idea of robots and how we would interact with robots, right? 1919. And these were just our dreams for the longest time. And we wrote about them. I don't know how many of you are science fiction readers. I've been reading science fiction for a number of years. We dreamed about them, and they became possible for us. But of course, when the first ones were possible, well, really the purpose of version 1 of anything is to inspire people to do it better. So these technologies went from a dream to not impossible. But again, there's a slow and steady change where, if you look at, say, for example, these robots designed to be able to play a game of football, at first you were lucky if they were able to play, if they're able to even find a ball, let alone play. But as the years change, as people worked on them, and as this became a technology available to college students and high school students and people playing with it, it got better. And they went from being able to not being able to find a ball to being able to play, again, it looks like a fairly reasonable game. And of course, the use for these isn't just gaming, right? If you think about things like earthquakes, and we just had an earthquake here in California last week that reminds us of how important it is to have tools which allow us to both predict earthquakes, but then also to work with them afterwards. You have situations where you need, where people are going in to do rescue work, and we want instead perhaps have robots go in to do rescue work. And here, 7 years ago, uh, a couple of photographs from the DARPA challenge where humanoid robots which are able to go and deal with human-sized and human-shaped tools, were trying to, well, go in there and be able to press a button, go in there and be able to move a brick. And if you went to the challenge and saw the challenge 7 years ago, you'd say, this is going to take forever to be able to work. I mean, if you look at these robots, you will see that each of them, they have ropes attached to the top because these would easily fall down. And if they fell down, you were not able to get them up. But from 7 years ago to 5 years ago, so only a change of 2 years, these robots went from, well, all right, they're barely working, to ones which successfully were able to go and pick up tools, do things, change things, walk around. These are pictures that I took. I had the amazing experience to go with 10,000 other people and cheer as they were going. Now, of course, these robots were very slow. These robots took 30 minutes to do what you and I would take 1 minute to do, perhaps. But again, the nature of exponential technologies is that when something is, once it exists, and it slowly but steadily gets faster and better, well, it takes 30 minutes, and it takes 5 minutes, it takes 1 minute, it takes 30 seconds, and the next thing you know, these could be faster than humans. And as I say, these were, here's a picture of the winning team from KAIST in South Korea, and these are college students and others working on this. This is not, giant companies working on this. Here's another area, of course, with exponentials. When you think about communications and satellites, for the longest time, satellites are something, if you wanted to build them, you had to be one of the, you had to be the European Space Agency, or China, the US, Russia, and you'd have to spend 500 million euros to be able to build them. But as these technologies are getting cheaper, smaller, and most importantly, into the hands of more people, satellites move from something that you had to spend $500 million per each to something where, here's people that I know who I've had the opportunity to work with at Planet in San Francisco, who are building satellites not for $500 million, but for, I think the current cost right now is about equivalent of 100,000 euros each. And this is not what we would have necessarily predicted looking at the satellites, what could happen, but here it is, and these exist because of exponentials. And here's another area when we think about it, who was it who mentioned that they're working in autonomous cars? It's not a change in technology, but just simply having smaller size. When autonomous, you could have built perhaps an autonomous car 20 years ago, but the computing would need to fit inside of a truck. But as it got smaller and smaller, you got to the point where the computers necessary, the computing capability necessary, could fit inside of the car. And of course, it almost entirely filled the car up at first. And I've had the chance to be able to meet with the people who worked on it, and then also know people who've worked on the Google project. As it got smaller, the capabilities got better, and now we're living in a world where these cars are starting to drive around, and they're not 100%. We have a Tesla ourselves, and sometimes people think, oh, that's autonomous, and it's like, no, not yet, but we can see the patterns. Now that it's not impossible, we could imagine what it's going to be like in a few years when they are not just possible, but safe. Or one that I love is, we talk about, what we dreamed about is we dreamed about translation. And, this is now over 50 years ago that we first saw this. But even 10 years ago, when our Vulcan president met with her, translation wasn't there yet. And of course, some people were hoping it would be rather, that's going to come really quickly. And this is where I'll go into a little bit later on. Why did people think that it was going to be happening by the 90s? And yet, even 10 years ago, It wasn't there yet. But again, because of the nature of exponentials, where you have slow and steady changes, and then combinations, tools, the number of people working on them, it goes from being uh, years away to you get the early inklings of it, not perfect, and then we have what we have today, where you have people. I've been to a conference just a few days ago where you have real-time translation, and the translation is very reasonable. So yeah, these are the natures of exponential technologies, and you've known this before, you've seen this before, but let's start talking about this, how this applies when we are working on solving problems. And one major point with all of these exponential technologies, and as I say, computing is one that I've worked with. I've also done some work in medicine and done some work in energy. I'm actually, in my past, an energy economist by training. Is we need to understand with all of these technologies is that these technologies are in fact really old technologies. And sometimes people will say to me, what new technology are you excited by? And I've been training myself to work and to not be able to be excited by the newest of technologies, right? Because when the technology first comes out, that very first version, you don't even know if it's going to survive. You see the first demonstration by a company, they might be too early. On the other hand, all of these technologies, which are 30, 50, 70 years old, they have become cheaper, smaller, more available, and most importantly, they're in the hands of many more people. And these combinations, especially being in the hands of so many more people, are what creates the changes that we are able to do. Now, I want to talk about now experts, the smart people who are working to solve big problems, the people who are working to solve the most important problems that we might be having to deal with today. And as I said earlier, you could also call these smart people. And one thing I've noticed is sometimes you have smart people, they don't like being called smart people, or sometimes you have experts and they don't like being called experts. So think about it, whichever one you want to do. Let's go back now when we think about these changes in technologies. And when you start zooming in on these technologies, each one of these technologies, each one of these revolutions that happened comes down to a group of people. For example, here's a picture of Gordon Moore and the rest of the team at Fairchild Semiconductor. And this is a picture when they were, if you come to Silicon Valley now, which hopefully in a year or two you'll be able to do, if you meet them now, some of these people, there are, statesmen and the elders of Silicon Valley. But at one point, they were 20 years old and just another startup trying to survive. And so I want to talk a little bit about these guys. Or another person that sometimes people don't think about as entrepreneur. But here's a picture of Marie Curie, and I've been working on educational materials in the future of science, and I'm using Marie Curie as an example because one thing people don't know necessarily is that, what was she doing 105 years ago? She was out fundraising, and she was fundraising for a mobile health application. She really was, because she had this idea. Now, just imagine it's the year 1914 instead of 2020. Marie Curie was out there saying, look, there is a old technology called, electricity in the generator. There's a new technology called the X-ray, and there's another new technology called the vehicle or the truck. What would happen if you did a convergence of these? What would happen if you put an X-ray machine into a truck? You would be able to deliver these services, X-ray services, out into the field. And when she was talking about delivering them, she meant bringing them out to the battlefield. And, here's an example of somebody, scientist, introvert, somebody who loved working in her lab and was happy to work 12 hours a day in her laboratory, saying, we can do more than just do research with this. There's a problem that needs solving. I'm going to help us go out and solve it. Now, before I want to give a couple of analogies about how and what happens at the intersection of experts and exponential technologies. Now, how many of you have heard the statement that if a person is out in the woods or you're out in the desert and you're lost, there's a fog, you can't see the sky, and let's imagine that you don't have your cell phone with you, that people not only will get lost, but they will walk in circles. How many of you have heard this? All right, some of you have. Well, scientists have checked this, and as a matter of fact, this is true, that if you take people and they are lost, they will go out. They're not always going in exactly the same direction, but people will go out and they will start walking in a circle. Now, why is this? Why are they walking in a circle? Well, you have to imagine that as you take step by step, if there's even the slightest difference between when you step left and when you step right, then you might lean, again, just the tiniest little bit, and you wouldn't even notice this lean as you're walking. But if you're taking 1,000 steps, if you're taking 2,000 steps, you're going to have a bias. You're going to start leaning in one direction. And even without knowing it, you will be walking in a circle. And I want you to just think about this. Now, is it 100% because of difference between gait? We're not sure, but we've seen this over and over again. So this analogy of, what happens if you're lost, what happens if you lean a little bit, that you can end up just staying in exactly the same place. Keep that in mind. And there's another analogy that I want to be able to use. And how many of you have done weightlifting? Yeah, most of us have done this. And of course, when you start out weightlifting, what do you need to have? You need to have a coach, right? You need to learn how to do it right. But there's another person who's even more important than that, because for the rest of your weightlifting, you want to have a spotter, right? That spotter is a person who is standing by you, and if your weights, if as you're lifting, as your repetitions are going well, that spotter isn't really doing anything other than they're keeping an eye on you. But if you're starting to find yourself, your angle is going the wrong direction, or you're not able to make that last little bit, that spotter just gives you that nudge, that push to be able to keep you going. And if you think about uh, a person who is an expert weightlifter, somebody who is not just weightlifting for fun or for basic exercise, but they're going to Olympics. At the Olympics, you don't have one spotter, right? You're going to have 4 spotters. You never outgrow the need for a spotter. So I want to, again, keep that analogy of spotters in mind as we go into talking a bit more about the intersection of experts and exponential technologies. Now, again, let's go back to this group, Fairchild Semiconductor and Gordon Moore. We think about them, we hear about them now because they're very successful. But as they started off, and it's an amazing story, I can give links if you haven't followed it, they were in a position of absolute desperation. They had built integrated circuits, which were going to replace buying all these different discrete components. Instead of buying 20 discrete things, why not just buy one package? Nobody wanted to buy them. And so they didn't know what to do. And they were sitting around and somebody said, well, we're going to go bankrupt. Instead of going bankrupt, why don't we announce we're going to have a sale? We're going to sell it for, we're going to offer it for less than what it costs us to build it. But if we get enough offers, if people want to buy it over 6 months, we'll figure it out. And that's what happened. They offered it at a cheaper price. People wanted to buy it. They said, hey, this works. And they did figure it out because they started to, having more scale. So it turned into a pattern where every year, every 2 years, they'd say, all right, for the same amount, let's reduce the price. For the same price, let's offer them more. And this is actually like a very first dot on one of those charts about what is available to us. But this decision was not made by a group who knew what they were doing. And it was, though, made by a group of people who all learned to talk and to trust each other and came from a variety of backgrounds. Here's some of my favorite quotes about these processes, where Gordon Moore, he's talking about how did we figure out even how to build these? Well, they had different background talents. So some of the people, they figured out how to be able to use some of the lenses from movie cameras to be able to start building what they were building. Because of course, what they were building, the tools to build it didn't exist yet. And the people, some of them were electrical engineers. Jay Last, as he was talking about it, he didn't know much about these technologies when he came in, but his ability to understand the physics, that helped. And here's, I think, one of the most key quotes about how they worked. There are 8 of us. We had different skills among the group, but within the group, we had all the necessary skills, and it was a completely cooperative effort. So this combination of having diverse groups of people who are able to talk with each other and a push, a nudge, a reason to be able to bring this together, in this case, because if they didn't, they were going to go bankrupt, that made these changes. Now, again, with Marie Curie and her work on building these ambulances, she didn't just make these happen, she learned to drive. And you have to imagine now during World War I, she and her daughter, Irina, who was, I think, 17 years old at the time, were out there bringing these to the battlefield. And not just bringing these to the battlefield, but they had to be out there yelling at surgeons, saying to them, stop poking around randomly, you're going to kill the person. If you take an x-ray, you can see. You don't need to slice them open before you know where it is, because there was a lot of resistance to this. Why would you need to have this? But as it became demonstrated, as she showed it, uh, then she started training other people, and different, this is in France, but other countries came in, and so it started to grow. But here is one of my favorite quotes about her process and how this happened to exist, is that, yeah, at the time, because it was World War I, people were saying, what could we do to save lives? Because unfortunately, these new technologies had found new ways to be able to kill people. And she came from the outside, right? I mean, she's a Nobel Prize winning physicist, or in a lot of ways, material scientist. She was not in medicine, but she was able to bring people together and have them start working on it. And here's part of the quote I think is most important. The people who did not understand, they gave in, they accepted it. Those who did not know how to do this, they learned. Those who had been indifferent became devoted, because the scale of the problem was so large. It pushed people into doing this. This was not automatic. This was not inevitable. This is a person who was tenacious and dedicated and could see what was happening, going out there, raising funds, building these, demonstrating it. And so this is part of, I want to now go into, giving these backgrounds. What is the nature of when experts are working on problems? Because one of the nature of experts, people who have already been working on a problem, for example, is experts tend to believe they know who needs to be in the room. They know who is going to be able to solve the problem. But of course, if you think about it, if you've got a group of people, whether it's physicists or physicians, who've been working on a problem for 10 or 20 years and they haven't solved it yet, why is it that they think that continuing with the same people is going to be, something is going to change with that? Here's a good example from almost 10 years ago, where, and again, we think about all the different ways of bringing people together when you have hackathons and when you have competitions, where you had physicists who'd been working on a particular problem for a number of years. They opened it up, they brought people in. And if you'd asked ahead of time, if you'd asked all these expert physicists, who do you think is going to come up with a breakthrough? And you got the list of it. I'm pretty sure that a PhD student who's studying glaciers was not going to be anywhere on their list. And yet, in this case, the PhD student, the algorithms that he had built for his own work applied. And because he knew about the problem, because there was a situation where he could come in, he was able to bring it in there, and his work transformed the solutions to this particular problem. And when you look at competitions, and when you look at even areas, just Silicon Valley in general, this happens over and over again. Another area in which we think that we need to know who needs to be in the room is in, say, Silicon Valley itself. And how many people have, met or talked with VCs, and you ask them, well, I want to take a step back. This is a really key and critical point. Even people who work with exponentials, even people who work and have seen changes happening, can still make mistakes and can still get locked into their own head. And this is an area where I want to go back to that analogy of being lost in the woods. Because if you think about expertise as being, what are the toolkits that you have available to you? What are your shortcuts? I think the technical term might be spidey sense. What do you think is going to happen? You are moving along and you have a choice. You can go one way or the other way. And one way is thinking entirely differently, bringing in people from the outside who you do not know, who have never worked on the problem before. Or another way is to lean in towards what you're comfortable, bring in the people who you know, bring in the toolkits that you're familiar with. And as you're making decisions in this new problem, which way do we want to go? Do I want to bring in the outsiders and what I'm unfamiliar with, or do I want to bring in the people I already know? You're going to lean, all of us do this, you're going to lean towards what you know. And what this means is that over time, you start circling around as you're thinking about a problem. You're staying within your own head. You're thinking in circles. And as you do this, you might be thinking, aha, I am thinking outside the box. But unless you have particular tools, you're not going to be able to do that. So here's an example. How many people have heard VCs and other people saying, entrepreneurship, startups, this is an area which you need to be like Mark Zuckerberg when he founded Facebook. You're good if you're young, because they're energetic and they don't need to sleep. And of course, that's a whole argument itself right there. Sleeping is so critical. And then when you get the data of who is doing well, people under 30 versus people over 40, or people over 30, people under 30, they're doing all right. But people over 30 are also doing really good. In fact, when you look at top 5% growth, the top 1% growth, or having a successful exit, the ones who are over 30, it's not a very large percentage of anybody, but they do twice as well. And so, as I say, the VCs and other people that you've heard, I've heard 10 years ago, but I've heard even more recently saying, aha, this is, you want to be able, here's who we need to bring in the room. Well, if they go by their expectations about age, they're bringing the wrong people into the room. Here's more data about this, because again, a lot of times when you have experts, when you're relying on your gut, your gut feeling, when you're relying on your spidey sense, if you're wrong, what's going to help you change your mind? You have to spend time looking at the data. And of course, one of the problems with experts, and by expert, I don't even mean people who've been working on this for 10 years. I just mean people who've been working on this long enough, a year or two, that they think they have a sense of it. The data does not necessarily change. The data is not necessarily supporting what they believe, but how often are they looking at the data to be able to change what they believe? Now, here's another nature of the intersection of new technologies and exponential technologies and expertise, which is just simply when you're starting out, new technologies are very expensive. So, for example, when we first had submarines, you had to be just like space. You had to be a very large government to be able to use them. And I remember being a child and seeing these beautiful pictures from underwater and wanting to be able to go and do this sort of stuff myself, but I wasn't able to. I was limited to the dreams, the budget, the imagination of the people who could afford to build these. But here's a picture that I took from Maker Faire, a place that celebrates bringing people together who are just building. Open ROV, people who are building open source autonomous software and hardware for robotic exploration. And suddenly I'm not limited to the imagination of the people who are building $1 billion submarine. And of course, their imagination, they're going to say, aha, there's no room for imagination. We need to use this for a very limited number of purposes. We need to use this for security and for the military. And now instead you have thousands of these and millions of these being built, not by the experts, but by high school students who are saying, well, what could we use these for? Well, what do we want to use these for? We could use these to explore. We could put sensors on them. We could use them to discover pollution. And you are limited, but then not limited, to the imagination of everybody who has them. And when you look at the purposes that these are being used for, they are being used for important, incredible purposes, which, according to the experts and the people who were working with the expensive ones, 20, 30, 40 years ago, they wouldn't have known, they didn't expect you'd be able to do this. Because then, of course, there's not only the hardware, the software, but there's the data being collected. So again, going back to my friends at Planet, is that as these satellites became cheap, as they got to the point which exists today, where every spot on Earth is being photographed day by day, in some cases hour by hour, we start having uses that, again, you could imagine it. I mean, if you'd asked somebody 20 years ago who was looking at deforestation issues, what would they love to have? Well, they would love to have, satellite views which let them see change. But back then, if each satellite photograph cost $1,000 or $2,000, it was just out of reach. And instead, today, companies like Planet are able to make this data available to nonprofits around the world. So here's an example of not just satellite data, but convergence. If you're able to take if you're able to have these satellite photographs of ships moving around, you can detect if a ship is moving. The ship says, we are just doing one type of fishing, we are using line fishing, and they should be moving like this. But instead, if the ship is moving in a particular pattern that, again, 20 years ago, the military would have known about these patterns, but nobody else did, you can discover, these ships are doing drift net fishing. They're illegally in a particular area. So the combination of Planet and other companies having this data and a few other technologies together allows, here, for example, Indonesia. If you've read about Indonesia catching illegal fishing boats and setting them on fire, it's because the data and volunteers and everybody working together makes it possible for them to be able to see these illegal fishing boats and to be able to know where they are to go out and capture them. And these are the sorts of uses which we could have dreamed of even 20 or 30 years ago, but they exist today. Or even when you think about sort of the most, boring and basic of exponential technologies like cell phones and communications, you think about the digital divide, and or if you think about how people think about using the internet today, and people are saying, well, we have access to data, but you know, how do we know how people want to use these? Well, let's talk to people, let's have Zoom meetings and talk about it. They aren't necessarily saying, as the UNICEF, the UNICEF Innovation Fund did, well, if you need to talk to people, if you need to ask some questions, you don't necessarily need to have high bandwidth. You can just ask a question using SMS as long as you have a good database in the background. So they built a system, open source. It's being used in multiple countries for multiple purposes. For example, here is Nigeria, where they use this basic system. They use a researchers with phones, and not smartphones, but just a phone which has the most basic of 2G. Hey, has somebody been born in this area? And these nurses are recording childbirths. 10 years ago, many people in Nigeria living in rural areas did not have a legal existence when they were born because the data did not get to the government. Now, for the past several years, every child born in Nigeria has a legal existence because every child is registered, because people were saying, what do we need? What's the problem? What can we use for it? Who can help with it? And they brought it together. And they're not just using it for things like surveys, or for purposes like registration, but here's a different use of the exact same technology where they put this into the hands of high schoolers and ask the high schoolers, what do you think of this new law? Or in this case, have you had a problem with water scarcity in your community recently? And if you have had a problem, what do you want? What have you tried to do about it? And what I love about this example of what UNICEF has done here with this is that they made not a technology, but they made a process of being able to say, what happens if you just decide to ask everybody what they think? Now, I should say, in these countries where they're asking the high school students what they think, not every high school student has a cell phone, but most of them do, because again, it doesn't need to be €1,000 iPhone. It just needs to be a €10, €5 used feature phone. But that idea of, if you want to know what people think, go ahead and ask everybody. That is not the behavior of experts, because experts tend to, they'd be used to the idea of, if you need to know what people think, you need to be able to do a representative sampling survey and ask 1,000 people. The idea of just go out and ask everybody, that comes from people who have that combination of desperation, a great need, and diverse people coming together saying, what is possible that wasn't possible before? Now, just there's a lot more to say about experts, but I want to go into Q&A about that because, each one of us is an expert in our own area, but of course, each one of us is that beginner and the person who's able to ask naive questions. But another thing that Marie Curie said, and that's really critical to as we look at these big problems today, is that she said, when you're looking at the act of building and making, yes, humanity needs the people who are just sitting there building, working on things, going to be able to build a product, sell a product, make a product. But at the same time, humanity also needs dreamers. There needs to be the people who are asking impractical questions. What if? What if we could do something that nobody's imagining that we're doing? Yeah, again, in her case, what if we could take the type of giant X-ray device which normally would fit in a hospital and be able to put it into a truck at a time when trucks were barely in everybody's imagination yet? And this sits at that intersection of expertise and exponential technologies because when I work as an advisor to startups and people are saying, they're asking me, are you thinking about technology? Are you thinking about trends? And I say, no, I'm thinking about psychology. I'm thinking about, are we in the world where we're allowing people to be able to dream and ask questions and where the experts aren't immediately shutting people down, where in fact the people are in the room together and they're having the conversation? Or are we in a situation where the experts are saying we're moving so quickly that we don't have time to talk to anybody else and we don't have time to dream? And my argument is going to be that the world where you have people with the dreamers sitting with the practical people, when you have the experts and non-experts working together, you're going to be solving a lot more problems than what we have today. So that's the end of the presentation, and I'd like to jump into Q&A, and I'm sure, Nikki, you have some good questions.
Um, Bam, what a philosophical journey. Thank you so much for this. I have to say that since 2015, when I got introduced to singularity, the concept of exponential technology and the concept of exponential growth and what it means and all the patterns have become more and more familiar to me. And I'm actually doing workshops on exponential growth strategies, and I'm trying to help people understand what does exponential actually mean and the mindset and everything. And I haven't had that journey yet. So thank you so much for this. I have to admit that this is a lot for me to process and kind of to revisit my own understanding of exponential and how I can bring this to a next level.
Yeah, well, so
I'm curious to hear from you when you look into the connections been made in the past and the connections are right. So what I think is really beautiful, it's totally technology agnostic what you're sharing, right? It's kind of we could go at any data point of your talk in chronological order. The technology didn't play a role. It's kind of how people saw things fitting together, what was mattered, and what actually made impact. And you shared the story about the feature phones, and there's so many stories that are not past. They're not historical stories about how feature phones have made a difference, right? M-Pesa is such a celebrated story about how a feature phone can create awareness about financial literacy actually in a whole country, and on and forth. I'm curious to hear from you when you see these patterns, like connecting things on a meta layer and not following and chasing technology to figure out if there's a business model behind existing technology or future technology. What are I know it's a very broad question. What are the top 3 things that you think work really well right now, and what are the top 3 things that you feel like they're totally going in the wrong direction right now?
Well, for what's working really well right now, I think, again, it's technologies about technologies. For example, when we're looking at the response to COVID, one of the technologies in science, which has grown really rapidly in the past 15 years, is the idea of community models, right? If you think about science 20 years ago in many fields, I have my laboratory here, and we've got our models and our computers and our data sets. And you have your laboratory here, and your computer and model and data sets. And maybe every 3 years, we get together and we compare notes. Instead, they were saying, look, it's the 21st century. What would happen if we've got a shared model in the middle, and each of us contribute to it? And say if I'm working on water quality, I might be focusing on this side of it, and you're focused on rainfall, and you're working on that side of it. But still, We know what's going on, like open source software, you're able to see changes immediately. So it was both, the technology made it possible, but you had to practice this. You had to get used to the idea that you've not got a secret model and you're going to prove how amazing it is. Everybody's going to get to watch you changing it week by week. So you're more familiar with each other. And so community models is really important. Now, with COVID, we are starting to see the community joining community models. And we've seen it before, but now science itself is open and visible. And it's created some difficulties, right? Because if you're in science, you know how sort of slowly things can change, and here's a hypothesis and here's an idea, but it doesn't quite work out, and a year later you've had to change things. That level of non-certainty, when people from the outside are watching and saying like, wait, you're the expert, you should have certainty and it should be fixed. And so right now we've got the chaos of understanding several different things, one of which is that no, science doesn't work that way, but also scientists, they love to come and talk about the results once they're done. Experts like to look certain. How many people want to be able to go forward, whether you're a CEO or just starting and giving a pitch, or you're a scientist, and be able to say, well, we've got this data, we've got this hypothesis, but who knows if it's going to work. We don't like saying that. We don't like looking uncertain. And so, because a lot of times we feel that looking uncertain makes us look like we're not an expert, even though that uncertainty makes us look even better. So for example, when I'm working with any type of organization, like say a few years ago, I had the opportunity to go to a major energy research laboratory in the United States, and I realized something. I could go and talk to them about innovation, and I could give them 50 examples of startups in energy. And you know what? There's going to be that person in the front row who's just going to be, that's going to fail, that's going to, you know what? They're right. 45 of those 50 startups are probably going to fail. But that's not the point. The point is that there is this energy in energy, that these people are doing what hadn't happened before. So I realized I can't tell them. I mean, I have some energy economics by background, my master's degree. I can't tell them about them. So I gave my talk and I told them about startups in space. Because space, as I said, is an area where you had to be a giant government or a billion-dollar company to be in space, and now it's a field of startups. And I had to give them some tools and ideas about what's happening in space and how space has changed. And they're going to have to come to the conclusion themselves. It's like, wait, if space is an area where you used to have to be giant and now startups are in it, why do I think that energy is immune? They had to come to that conclusion themselves. If I had tried to tell them that from the start, they wouldn't have believed me. So right now, even with science and how we talk about science and how scientists interact with the public, you can't really tell scientists about how things are changing, but you can tell scientists about, well, look, here's what's happening in open source software. Here's what's happening in hardware. And again, it used to be you had to be a giant corporation to be able to do it. And now open source, but not just open source where people from the community are coming in and helping, has caused this rapid change. Why do you think science is different? You've got your in science community models. Now we have many people coming from the outside. Why do you think that that's not going to change and create tremendous growth in the speed of science itself, just as it has created tremendous growth in the field of software and hardware?
Amazing. Kathryn,
Sorry, no, I didn't answer your question about the three things which are going
yes. Second part.
wrong. I think that's just typical, is that when a new technology becomes possible, people start immediately imagining all the ways in which we can use it. And there is still always this long stretch of time between when it's not impossible to practical. So some of the technologies which are, well, again, things like blockchain, they are old, I mean, in the sense of being 10 years old, but still people start promoting blockchain for everything, and blockchain and the grandchildren of blockchain will be used for everything. but we're still at that point where the purpose of version 1 is to inspire other people to do it better. So any new technology, I mean, it's necessary to have people promoting it and saying all the amazing ways in which we're going to do it. That's what creates a self-fulfilling prophecy. But the idea that a technology comes out and instantly 2 years later you've got a giant ecosystem, that doesn't happen yet. I think you do need to be able to have technologies that are outside of the laboratory and outside of the hands of any one company. Once they're in the hands of 1,000 companies, that's where they take off. So any technology where there's really only one company doing it and promoting it, maybe they'll win, maybe it'll become amazing, but historically that doesn't happen yet. Historically, the first people who build it, they sort of say, well, I'm the expert, our company built it, we're going to think of the ways in which it's used. And when you look back, the way technologies are used are always very, very different from what the original people imagined. And there's no shame in that. But the sooner a person is able to say, well, I feel like I can come up with all the uses, but no, let me share it with 1,000 people and see what they come up with. Let me share it with 1,000,000 people and see what they come up with. That is a way in which experts have to learn to say, well, maybe I'm right, but I'm not right until I test it.
Martin, I think you had a question.
Yeah, I have one question. No, maybe more question, but
Sure.
For this time, it's maybe not able to answer our question. But I have heard about the Singularity University that they have special curriculums. So managers come back every year, and then they get an update about the newest technology, so they can think about it, and you go on and go on to confront them with the newest idea. And can you tell me a little bit more about this project? Because what we have with our startups, they're not on the last state of the technology, and they think about solutions they actually old. So how can you bring people on a level that they think from the actual situation and not what is going in the past?
Mm-hmm.
So not
So
sure it's brought my question on a point, but I hope you get an idea what I'm asking.
let me give you what I think. Here's what I am thinking. Remember, I gave that analogy of the weightlifters, and that when you're doing weightlifting, you have to have a spotter. And the idea is if you don't have a spotter when you're weightlifting, you're going to get injured, right? Because if you're pushing yourself beyond what you could do before when you're weightlifting, that means you've got the possibility of failure. Your muscles aren't used to this new weight yet. And it's almost by definition that you need to have that person there watching, because if they're not there, you're not going to be able to at first do more than you've done before. So when you have people, they come, they listen about these new technologies and they hear about them, then they start having these ideas of, all right, these new technologies are here. We need to be able to bring them in. Just all the arguments that you would hear about about disruption and not getting used to it. And then when you get back, you are still motivated to be this way. But remember what I said about sort of leaning in towards your expertise. You have you're bringing the engineers in together and saying, all right, how are you going to use these technologies? And the engineers will have an opinion. However, remember what I said about people saying, oh, experts think they know who needs to be in the room. When you have the engineers talking about the new technology, what happens? Perhaps you're not bringing in the rest of the company and asking them what they think. You're not bringing people in from the outside, because again, you're more comfortable talking to the people who already know the language that you know. And so you start drifting back towards being complacent and comfortable and not using these tools and bringing in these ideas. So when people come back to programs like Singularity Universities and other programs, now this is my take on it. It's a little bit about learning the new technologies, but it's mostly about reminding people about the mindsets, having them meet other people who have gone through exactly the same issue and have them talking about what allowed their company, their organization, their nonprofit to stay on track. And to be able to stay on track, you cannot stay on track by yourself as a CEO, because you are inevitably going to be able to sort of drifting back into your own comfort zone. You stay on track because you have other people around you who they not only have the ability to tell you that you're starting to drift away from what you said you're going to be able to do, they have the motivation. And it's really hard to do, right? How many people want to be able to go to you as a CEO and say, look, you said that we're going to be changing. We can't do it as we've done before. But you're going back to making all the decisions, and you're going back to being comfortable. It's really hard to do that. The only way that you might be able to motivate it to do that, if you work, for the CEO, is to say, well, no, me coming in and telling him that he's changing, that's the same as being a spotter in weightlifting. If I don't say something, this is going to keep on happening. If I don't say something, you as a CEO are going to be doing the equivalent of dropping the weight, making a mistake. So the purpose of coming back and learning about these technologies, for any technology to change year by year, once you understand that we've gone from here to here, and then now we're filling in the details, that's not the part you necessarily need to do. But you need to be able to come in and listen to, what are the startups who existed last year? Are they still in existence, and why have they failed? So you're really coming back to learn not about the technology, you're learning about psychology.
Kathryn, I have one. You just blow my mind constantly. I feel like I still would like to add, if that's okay for you, because we're 3 minutes to the hour. We have one participant here in the room, Simon, who's growing, I think, the most important project in the world right now, at least one of the most important projects. It's called Moonshot Pirates. And with his team, together with his team, he's educating, informing, growing, encouraging, and helping 16 to 18-year-old kids to understand what world are they walking, steering towards. I'm curious to hear from you, without him having asked that question. I'm curious to hear from you, what would be your message to the 16-year-old today?
My message is going to be that each year we are seeing the scale of the problems, the problems that we have right now when it comes to climate science, or the future of work, or any of these other major, any of the sustainable development goals. Our ability to understand them has been growing, which also means our ability to be depressed by them has also been growing, because just take a step and think in general. If you've been working on a problem for 10 years and you're dedicated to it, say the future of food, everything that has gone wrong so far. All the ways in which it seems like it's insolvable. Now, deep down inside, you do believe it's solvable, because you are working on it. Why would you work on something that can't be done? But if you've been working on it, you as an expert are going to have let's call it like an allergic reaction to the idea of like, oh, it's going to be solved in 5 years. Oh, somebody from the outside is just going to be able to come in and solve it. And so you as a 16-year-old, you as an 18-year-old, you need to understand, like, how is it and why is it that experts seem like they don't want to listen to you? And they seem to be treating you as being naive. And if you understand the nature of expertise, and I'm not saying this is not necessarily even arrogance, it can be realism, to be able to, when you look at the scale of these problems, the problems that affect 1 billion people, it would seem naive to be able to say, oh, they can just be solved. Let's just throw some blockchain at them. These can be solved. Let's just ask an AI to be able to solve it, right? Deep learning, yay, we're done. But if you, as an 18-year-old, understand what it is like to be a beginner talking to an expert, and understanding why an expert is having this, oh, they don't do this, but deep inside they're sort of feeling like, this is a naive question. I don't understand. If you understand that about experts, then you can say to yourself, what is it that I need to do and to build to be able to get around this, because it is your responsibility to be that spotter. If you see a group of people who are working on a problem, it is only going to be solved because the rest of us are joining in to bringing the tools, the ideas, the help from the outside. So, understand what it means to be an expert, understand what it means to be a beginner, and of course, the discomfort of being able to say, oh, I've heard about your problem 5 minutes ago, I think I can help you. And if you understand the psychology of the experts and the beginners, then you are able to come in and, don't worry about them being grumpy. Don't worry about them having that allergic reaction. You're able to work with them because you need their expertise. They are going to be the ones solving the problem, but they're going to be working with you to solve that problem. So as I say, understand the psychology of expertise, understand the psychology of being a beginner, and understand by looking at the examples around the world of what brought these groups together to solve the problems which we already have been solving.
What an elegant and beautiful and insightful question. And I'm gonna edit. So the whole session is recorded. I'm going to make a special edit for the Moonshot Pirates with this quote, so share it with their, because I think it's information. Thank you so much. I have actually one closing question, and that's, I know this seems like the most profane question you probably have ever been asked after a talk.
I've had so many questions.
How do you freaking get that Zoom thing work behind you? What's that?
I'm going to tell you. I can tell you more about it. Later. Let's see if I can get the. Yeah, this is what I really look like, right? So this is using a software package called OBS, which is a open source package that gamers use. If you look at those videos where you've got gamers and they've got the video game behind them and they're putting it all together, so we're using that to be able to put different, to be able to move different, to have different sources put together. So yes, I'm able to have me at different sizes, or me not in there at all. And of course, I can change what's behind me a little bit. Sorry, just a second. Where is it?
Is it actually really behind your house? Is it kind of something you've recorded to make us believe?
Yeah,
That's nice.
yeah, we recorded it out the window.
Oh, come back.
So it is. And by the way, everybody, Nikki, if people have further questions about it, because this is I wasn't able to take questions from everybody, but as I say, I give talks to be able to have conversations afterwards. So if anybody wants through you to reach out to me and have any additional questions about this sort of stuff, I'm always happy to be able to help. Because whatever you're working on, I'm certainly a beginner on that. So perhaps I can ask a couple of naive questions.
Yeah, I have a naive question.
You all, Martin, you can all take it from here after this.
Okay.
I know that Kathryn is offering this. This is not the polite way of saying goodbye. This is an honest invitation to keep that conversation alive. So stay in touch with her, ping her, share what you're doing, share your worries, your fears, your questions. To take it from here, this is the beauty of these conversations, right? You can offer this if you have a few people around you. You can't offer this if you're talking to 500 people, because that would make the end of your next 5 weeks looking at the inbox. You might have to delete your email and find a new one.
Yeah, you'd think so. Actually, a lot of people, they don't necessarily reach out. And a lot of these topics, what I've discovered is, if you give people some tools, and I hope you enjoy some of these background tools that I've put in there, like what I said about the space versus energy, right? You tell the energy people what the people in space were thinking, and then they wake up. Maybe they don't even get it that day, but 2 days later they wake up and they're like, oh wait, she was talking about us, wasn't she? So if anything that I've said, if 2 days from now you wake up and you're saying like, oh, she was talking about what I'm doing, Yeah, because sometimes we don't think about ourselves that we are the experts who are having an allergic reaction to somebody else. But I'm saying this is human nature. If nothing else, remember what I said about the people being lost in the woods. If you have been working on your problem for 6 months, a year, 2 years, you've got the tools you are comfortable using. And even if you think you can think outside of your own head, you can't. You are going to lean towards the tools that you are used to. And so your ability to bring in people from the outside who say things to you that sound naive and that you're uncomfortable with, going back to Moonshot Pirates, the other thing to remember when you're 18 years old is you are also an expert. You're certainly an expert in your own life. You're an expert in your existence so far. So at the same time that you're sort of looking at this expert and saying, why isn't this expert listening? You yourself are going to be doing exactly the same thing. And that's why it's really important to understand the properties of experts and beginners, because you always think, this is somebody else who's doing it, and you forget that you yourself are doing it. You yourself always need to have your spotter, because if you are pushing yourself beyond what you were doing before, you have that it is the human nature. You start thinking inside your own head. You start going back to what you were doing before, and only with these outsiders, especially naive outsiders, people who are willing to ask these tough questions and like, why are you doing what you said you weren't going to do? When you're 80 years old, you do this. When you're 18 years old, you do this. This is a human condition. And so the more you understand that about yourself and learn to be able to, just enjoy that this is what it is to be pushing yourself, then these problems get solved, whether it's a problem at your startup, whether it's a problem with the future of work, or whether it's a problem with working on the climate itself, or especially right now, how we work on COVID.
Kathryn, thank you so much. This is maybe something like the 35th or 40th meeting in the virtual conversion of the tour program. I've never had so much beauty in a room, like in your words and in your insights, and then in the thoughts you've ignited. Thank you so much for this.
All right. Thank you.
And you guys revisit it. If you want to stay here, guys, to reflect today's sessions, be there. And Kathryn, if you have to drop out, drop out. If you want to stay.
Actually, if you'd like me to stay a little bit, I'm happy to do so.
Whatever works best for you. I would like to invite you guys to open up your mics and share how you feel about the today and the two sessions, and what's happening in your life with how many buttons did we hit today, and what did that release? Maybe I want to start with Marcus.
Yep. Okay.
With Marcus or Martin?
Marcus.
Oh, that's me. So Kathryn, I thought it was great. So I'm based in the UK. I joined late because I was running a remote session with a couple of hundred kids in Armenia. And I'm also fascinated by Moonshot Pirates, and I'm helping. I think what you eloquently put together is sort of suggesting that the way in which we currently run business, which is to try and come up with ideas and protect them at all costs and patent them to stop other people, slows down the advance of civilization, doesn't it?
Well, I've worked in software, and right now also doing my sister and I are co-founding a nonprofit on the future of science, and yes, I think that it does. It is a testable hypothesis that you can come up with better ideas than the rest of the world, but so many people, they don't test it; they just assume it, right? And so it may be the case that when we're talking about solutions to COVID, that you've heard the people say, stay in your lane, and that scientists will be able to come up with the solutions. And I'm saying, well, that might be the case, but my Bayesian prior is that when you look over and over again around situations, you need to bring in those outsiders, and until you've tested it, that belief, it's just a random thought. And it's really funny sometimes. You have people who are data-driven, or you have scientists who are used to experiments, or you have companies which say they're data-driven, but they haven't run the experiment. Put it out there and see what other people come up with. You might be right. but you don't know that you're right unless you've tested it.
Of course, that's scary because it's destroying the mystique of the expert.
Johan, you said you have to jump. Is there anything you'd like to ask before you have to head out to your next commitment?
First of all, very insightful session. You know, I work in technology with patents, so I see a bit the future in this sense, and also the way our organization, which is a very rigid organization, this European Patent Office, managed to kind of increase the way, I mean, the innovation, right? I mean, everybody's now working from home. They had to rebuild all the internal tools, you know, this kind of collaborative working tools in a matter of weeks. And it was really like exponential. This, and also, you know, we had like one day to learn all of these new tools. And what I take out of this COVID crisis is, and this is actually also a question to everybody. You know, I realized on myself that with this, you know, the way I was living previous years, I kind of didn't really focus on my ability to learn very fast new things. So how to learn, and yeah, this, I mean, in these past weeks, I really had to learn new things really fast, you know, new technologies, I mean, I also changed my field of work because simply in my old field, databases, patent applications stopped. So then, you know, the only way to stay in the business, you learn a new field. So I had to learn all about these convolutional neural networks and autonomous driving in a matter of 5 weeks, really fast. So I was following online courses, you know, Coursera, books, YouTube videos. And how do we maintain, you know, this ability? Because I think this will become more and more frequent, that you simply need to either change completely your work or the way you work. This is for me, like now the biggest question, like how do I maintain my ability, you know, as I also grow a bit older, and, you know, we know that these cognitive abilities tend to decrease, to really like learn fast, right? This is for me quite in line with this exponential technologies, right? So that is a bit my reflection right now. And this talk was really useful for to get a bit of insight and a new perspective. So thank you for that.
Yeah, you're doing the right thing by being here. No, one of the reasons I mentioned Marie Curie as, or you know, talking about Fairchild in the first Silicon Valley startup, is that desperation and being in a new situation creates a drive to be able to do it. Yeah. And so right now, you know, millions of us, hundreds of millions of us are in this situation where we need to be able to change. And we are discovering that by being pushed into doing it, we are, you know, it happens. And the one thing that comes out of it is, I think we need to practice this sort of stuff. Yes. And give ourselves time to practice. And here's where the problem comes in companies, which is in companies, a lot of times when you tell people we are going to practice, we're going to have a hackathon inside the company, what happens, everybody shows up in the room. Let's say you're an energy company, and this is a real case, where they're saying, all right, we're going to bring everybody together and we're going to think about the future of energy. And I say, the hackathon part is a good idea. But remember, you're sitting at these tables together, and you're sitting at the table with the CEO of this 100,000 person company, say. Whose idea is going to come from that table? You know it's going to be the CEO's, right? Because it's a smart thing to do, is to say, yes, you're right, that's a great idea. So I said to the people at this company, if you want to do your first hackathon should be future of community healthcare. Why? Because everybody there, you know, we all have an experience of healthcare, and, you know, we've all had ourselves or a loved one dealing with healthcare, and we are all equally beginners if it's a company of energy people together. So, you know, the person who is not technical but has really seen the problem when, you know, that person's parents were in the hospital, they will have an idea, and the CEO will, that's a good idea. And by practicing it, people will say, aha, the CEO, my manager's manager, they're comfortable saying, let's go with your idea. My idea is not so good. And once you practice that, then when you have it for real, talking about what the company does, people are comfortable. If you have to be perfect right off, you're going to fail.
Mm-hmm.
Yeah,
So the point here is to always have this beginner's mind, like approach things, like always take a step back. How would an absolute beginner deal with this situation, right?
That's one step. And the other step is to realize, I give the example of exercise. If I told you I'm exercising, I took a class in exercising a year ago, you'd say you're not exercising. Or if I told you I went out exercising yesterday, my heartbeat didn't change, nothing changed, you would also say that's not exercising. If you're pushing yourself, you're going to feel uncomfortable. Yeah. It's by definition, that is the nature of it. If you're pushing yourself, you've done things you haven't done before, that feels strange. And so becoming used to that feeling of like, oh, I'm feeling discomfort, that's not wrong. If you're about to ask a question and you're like, I don't even know if this is a good question. You're pushing yourself. If you ask a question where you know what the answer is going to be, you're not even asking a question, you're just doing a demonstration. So exactly. Teaching yourself to be comfortable with discomfort, that is where learning happens.
That's a great insight. Thank you.
Martin has been so patiently waiting to ask his question.
Okay. What I have already now in mind, since I don't know when it was exact in the point of your presentation. I was working, this is also a lot of years ago, in a company now called Infineon Technology. Maybe you have heard about this. It's a chip company. Yeah, Infineon yes. Technology. So this time it's had another name, Siemens Bauelement UHG. And there was they had a claim in the marketing. They said, never stop thinking. So it's a nice saying, but the question is where to start with thinking. And because why I'm asking this is, as I remember in the Infineon time, of course we had a technology roadmap, but normally each technology company should have, and I think they have it. So if now, and I have a lot to do with startups, they start to think about the idea with old technologies, they think about ideas they maybe in Europe knew, but not in the world. So that's also one reason why I like these tours, because now you get where is the state of the art and where the people are thinking forward, because it doesn't make not sense for me to start to think about old things maybe you lose already on the market. It's too late. So where to start to think is now my question.
Well, so one thing say at a place like Singularity University or Google itself, if you were coming to Silicon Valley, I remember people would come visiting, and I think they would not with an appointment, and I think they were hoping that they would come in, and if they came in, Ray Kurzweil is going to be there building robots who are singing about mathematics. And instead, I think they would be disappointed to discover that most of the people working there are sitting there either building models, building spreadsheets, or having a meeting about spreadsheets and models, which is to say, whatever you're doing, you're a scientist, you're a CEO, you're in government, you're in policy, 99% of the time you're working. Like you have to sit and work. You can't go and talk about working. You have to work. The question is again, when you're doing weightlifting, like you're doing repetitions. And most of the time, like say, even at the Olympics, you're not in a competition, you're practicing for it. 99% of the time, you're doing your work. The question is, what are you doing those other times? And the number might change. You're coming up for air, you're looking around, you're checking with other people. Are you doing it in a way that if you need to change, if you are starting to drift away from your goals, or if your goals need to change, that other people can tell you that and you can tell them that? So it's a question again, with like the semiconductor industry, part of the semiconductor industry, yes, it's the ITRS roadmap, and it's a self-fulfilling prophecy. We are going to be, going down to 10 nanometers because we're predicting we're going to go to 10 nanometers. So that part of it isn't necessarily changing. But when you look at, for example, what happened to Intel when mobile became such a big force, or when you look at certain companies were able to, they said, we dominate this industry. We dominate, say, laptops and desktops. We can tell people what to do in desktops and laptops. And even if a company still dominated that, this giant other, like mobile came into existence. So they were not having hackathons. They were not doing, one of the areas that I work in, for example, is science fiction design, using science fiction as a toolkit to tell yourself stories about 5 years from now, 10 years from now, where you're able to say, well, what happens if we dominate an industry, but the industry is shrinking? Because like, you came up with a hypothesis, we're going to dominate this industry, and you're still correct. But in the big picture, you're wrong, because you're secretly thinking, and this industry will always be the big industry. So yeah, you have to do your work. You can't get away from doing your work. If you're doing a startup, you have to talk to customers, you have to build, all the rest of it. But are you doing it in a way where you are regularly checking in with other people and other people are checking in with you, so that you're changing your mind as you need to change it? You can't always be thinking. Most of the time you have to be doing. But are you thinking wisely? Are you asking questions, or are you just giving demonstrations of your knowledge?
I really enjoyed that, and I feel like, yes, you're so right with that, walking in circles, right?
Yeah, and I should say, look, if you're
longer than the other, whatever reason, we're always walking circles because of what you said right now.
Yeah, you have to have tools. In the case of, like, if you were lost and then you said, oh wait, I have a GPS, or you look up and there's a star, and so you're following that star. If you now say, I am now an expert at following the GPS, I'm now an expert at walking in a straight line, so you put it away and you stop looking, you go back to the circle. Like, it is the human condition, and the sooner we get used to the idea that, but here's something I've seen in startups, for example. You start off and you talk to your customers, but after a while, it's like, do I need to talk to my customers? I can just imagine what they're thinking.
I mean, I'm connecting the dots here, and I don't know if that makes sense for you, but I was working with Darren Dent from MIT, who's an inventor of all kinds. And he invented the navigation system that you put in your soul, and it would stimulate your foot nerves to make you walk somewhere.
Oh, nice.
And his idea, the tagline of this invention was, we've lost the art of getting lost. So he goes to places getting lost by intention, and then figure out how his legs would walk him back home. And I wonder if I listen to you and other kind of this brain that also kind of forces us to know, right? We want to know. We don't want to go to the wrong direction. We don't want to walk circles. We want to go somewhere. How much does this actually stand in our way to actually go straight? How much would we go straight if it wouldn't be so important for us to constantly know on the GPS where we're located?
You need to have all of it. And so I think that I guess the answer is always, it comes back to psychology. It's like, what are you comfortable with? But if you took a step back from yourself, what is it that you really want to happen? I think the number one toolkit I have is, and it shows up in many different ways, is just, how do you have a how versus why conversation? Now, if you are fixing a problem, if you are in a stable situation, there's nothing wrong with staying inside your own area of expertise, right? And that's what I want to be able to say, is that expertise is delightful, right? It is fun to be able to just sit down and start working on things, and it works well, and somebody comes to you and says, can you do this? And you do it. Like, you need to have experts. The only problem, what happens at that edge, right? What happens, a weightlifter is an expert weightlifter, but if they're pushing themselves to do even more, you have that spotter there because you just know, the art of changing, the art of moving somewhere new, you could make mistakes. That's a human condition. And either you say, well, this is what I want, or, the problem comes, you're like, oh, I'm going to stay in my comfort zone, not because you're choosing mindfully to stay in your comfort zone, but that's because your discomfort, you don't have comfort with the idea of leaving. It's like, how have you tested yourself?
Kathryn, so beautiful. Thank you so much. Thank you. Also, thank you for adding another 30 minutes of your time, adding so much value to the conversation and enriching and making it even more of an experience that's off the charts and out of everything before.
Rather embarrassingly, I've been making notes. One of the first times I've made notes. So you've got yourself to blame for that, Kathryn.
Look, notes are a good thing. It stays in our memory longer if you use multiple ways to process, right?
You're right.
Yes. I say, look, I have some notes here.
There's nothing written on that. That's transparent.
It was very.
Oh, sorry.
With your technology.
It was the color of the green screen. Okay, here, notes.
Ah.